Hello, everyone, and welcome to week 7 of Comp 6443. This week we're going to be talking about XSS. This is pre recorded because really fun times happened, and the recording I actually made during the actual shoot had no audio. So here we are on my home desktop computer. Yeah, let's get started. So, a couple of things just to remind you some of the XSS related challenges are out now. I believe next week we have a bunch more coming, including one that I made. Some are broken as well. Layoffs and jobs are notoriously broken. Thank you, at Melon in the Discord, if you want to complain about that. But these challenges this week are due week 8 Sunday. Same old, same old. Cool. Report groups. So the second report is not out yet, but it's coming soon. I mean, you can switch groups if you'd like, but ideally you just stay with the same group. But you work on the feedback that I will provide you. Now, marks aren't out, but I've marked everyone's reports. So all you got to do is send me an email after watching this video, and I will give you some feedback. That being said, the marks will actually be out at some point. I think we said around week 8 or 9. Yeah, so if you want some feedback, send me an email. Cool. All right, to get started, we're going to cover something really important, which is origin versus site. So, what is an origin? You might be asking yourself, it has to be to do with something on this colored screen. I apologize for this blue text. I'm going to highlight it so you can actually see it. Yeah, so like, what is an origin? Well, to put it simply, an origin is the scheme, being HTTPS or HTTP, the host, and then the port. So if you change any three of these things, then the origin becomes different. It is a different origin. And usually the origin is found in requests. When you hit your network tab, you can usually find the origin in a request. Let's refresh this. We see week 7, and we scroll down. Maybe we can't find the origin here, but usually there's an origin header that says this is where the request came from. I wish I could show you one, but I cannot, it seems. Anyway, so that's what an origin is. So if you change ports, if you change this like actual website, I guess domain, if you change the protocol, it is a different origin. Okay, now we have site. Now, this is very important that the site is this part, the example.com part. And the site is made of a private domain and a public suffix. Okay, so if we look up what a public suffix is, we have a big old list of public suffixes. And as you can see, there's a whole bunch. So you have stuff like off.ai, you have probably edu.au, all the different nsw.edu.au. So our uni email, the UNSW part is actually not the private part. That's the private domain, and then we have the public suffix being unsw.edu.au, right? So yeah, that's public suffix and then private domain. If you change these bits of the URL, you are on a different site, a completely different site. It's important to note because let's say I'm on localhost, like just hosting a normal web server, and I have one thing on port 3000, one thing on port 3001, which we'll see in a little bit. That is a different origin. Those two places are different origins. Thank you, Java. But they are not different sites because they're still localhost. Cool. All right, so what are some restrictions on these sites and origins, you might be asking? Well, first things first is the same origin policy. So, same origin policy is an actual browser feature. It actually exists within your, within your browser, and it was introduced in 1995. It basically restricts you from getting resources from an external website. So, for example, if you request something from another website, the same origin policy says that you can't access any of the resources because it's only accessible on the same origin. Yeah. So That being said, external for same origin policy is based on the fact that the origins are not the same. So the port it can be different, the protocol can be different, um, and the actual website itself can be different too. And there's a little bit of reading here if you want to go to my website and have a look. But a very convenient example of this is when I just click on this link. So for those of you who aren't aware of how I've actually loaded these slides, they are actually on a iframe. So if I have a look, we go into this div. Actually, I lied. It's up here. This is an actual iframe that is linked to another endpoint on my URL. I've then gone and clicked on a link in the iframe, which has meant that it's redirected me to mozilla.org. If we hit up the inspect element and click here, we can actually see very, very conveniently same origin policy blocked. So we can actually see that we've been blocked from loading this resource because the same origin policy says that I cannot load this resource. Yeah, so that's like a really awesome example that I am able to provide. But for real, if you want to go to that same website, you could just click on it outside of the open it in a new tab. But yeah, there are some information things on this website, so take a look. So why is this good? Well, basically, before 1995, when they introduced this, you used to be able to just send a request to a website and then just basically access everything about that website. So you could run JavaScript on it, you could send requests, you could set cookies. And this was way back when it was pretty bad. I mean, yeah, like it was pretty bad before same origin policy. So same origin policy is really good. And now you might be asking yourself, but Jesse, if we block all of these requests to the resources, how do we get our cute cat photos? Like, how am I able to click on this and then it loads in the iframe? Well, something called cause. So at this point, I'd probably ask you if you were in person who has heard of this, but for those of you who haven't, it's something that you will experience if you ever do a front end. The reason why is because you'll usually have your front end on one port being 3000, and then you'll have your back end on a different port being 5000. And as we are aware, changing the port changes the origin, and therefore same origin policy will block our request and say, well, no, you can't load this because it's a different origin. And that's where cause comes in. So when I click on this cat photo, I'll get a request, right? And we get something called access control allow origin star, which is really awesome. And this is cause. This access control allowed methods is also cause. And cause is the reason that you can sometimes bypass same origin policy. So yeah, so cause stands for cross origin resource sharing. So sometimes you'll need to access some sort of resource using images or videos for a website, for example. And this can basically be achieved by setting particular headers, those being cause headers. For example, the one we just looked at, access control allow origin star. If we actually look at the access control allow headers, we notice that there's a whole bunch of other access control. There's credentials. So this one says, tells the browser whether or not the server allows cross-origin HTTP requests to include credentials. So that is stuff like cookies, TLS certificates, authentication headers, usernames, passwords. There's methods. So if you only want to allow specific methods on that particular domain, there's allow headers. So particular headers are allowed. Expose particular headers, max age, request headers, request methods. There's a bunch of cause features. And basically, if you have a backend resource that you want to be accessible by your front end, you need to set cause headers to say access control allow origin to localhost 3000 on your backend hosted on localhost 5000, because that will actually allow you to load your cause resources. Cool. Can it be bypassed? Well, yeah. It's just a browser protection. It doesn't prevent the request. It'll actually still succeed. So if we go back to here and then hit inspect element again and go to the network tab, we'll notice that when we actually click this, it actually is 200, right? It's not like a 500 or 400 or like a not allowed for 3 or something. it's a 200. So the request is being sent and it's being received, hence a 200. But same origin policy is simply blocking you from reading the response. But that being said, like, would it block you if you accessed it through a script or a curl command? No, because your script or curl command doesn't have any protections in place that say you can't load this particular resource. So this is really confusing for most people. And to summarize, same origin policy prevents us from loading resources. CORS allows specific origins to load specific resources. For example, if I click someone's malicious link, because of same origin policy, if the malicious website that I've gone to after clicking the link sent a request to bank.com, the request would be blocked because bank.com has said, you can't access me unless you're on the same origin. So you're safe at the end of the day. Okay. Now, yeah, I wanted to quickly skip past some things because I had a cookies thing that I wanted to quickly talk about that I think I've kind of misplaced here. So more on this whole same origin, same site thing. Cookies also have a same site, I guess, functionality where basically when you set a cookie in a header, you want that to usually be propagated around your website. Why? Because, well, if you have a session token that's stored, you want that to exist on all of your parts of your website. Otherwise, like, you go to a different page and all of a sudden your cookie is different. Let's open a new tab on my website and see if I can kind of demonstrate this. So if we go to the memory and set a cookie here, so we'll see that there's a whole bunch of fields. We don't really care too much about this. HTTP only, secure, same site. So if I say like Jesse Murhi, same site is none, I think I said in that slide. Yeah. So we say none. And then we go to just like google.com. Hopefully this just works, but it might just reset our cookies. Okay. It didn't work the way I intended, but I think that's because I've just like kind of manually set it in my browser. If we had like a cookie being set in the headers, that would be a bit different. But anyway, so we have different settings for cookies. You have none, lax, and strict. So none means that cookies are always sent, which is what I was trying to demonstrate. But yeah, like it has to be in a header, and we'll see in a second. Lax means that it's not sent cross-site. So if I move from jmurhi.mov to google.com, it will not be sent. It's also not sent in iframes, and it's also sent in get requests for navigation. Cool. So strict means that cookies aren't set at all, and strict is useful for like authentication flows where you might have a token that's set, you know, for like one request to verify someone's identity, and then it's deleted afterwards. So we can actually see that the way this works is that you have your set cookie header, and then you just chuck a little same site equals strict or lax or none, and you're good. Cool. All right. Cool. Now let's talk about client-side injection. So just to recap on HTML, HTML is just basically a bunch of tags that look something like this. These tags are quite common. You have a div tag, which is kind of like a box container, and then you have a p tag, which is a paragraph tag. It's just like basically a string of text. And we've seen this in our developer tools. Like if we open up our dev tools, this elements section is basically what's called the DOM, the document object model. And it contains all these cool little tags in a nice way that we can kind of expand the tags and see what's inside of them or close them up. Yeah. So browsers just take everything in this, like, I guess, text section and then render it as HTML elements here. And it's really cool. Like what you could do is like just completely, like for example, I didn't want this HTML thing to be there anymore. I just press it and then hit delete, and then it's gone. Like the browser will literally take this and then reflect it on your screen and render it. And you can see a whole bunch of different tag names like body, div. This div, you know, for example, has a class on it. If I remove the class, I wonder what's happening. As you can see, it's like ruined the style. So it's pretty cool like that. Like you can literally change the way that your website is looking. That being said, of course, this only occurs for me at the client side, and if I hit refresh, then it'll just render back from the server. But yeah, that's kind of the DOM and how you can modify it and how the browser kind of interprets it. So in that case, like how would the browser know if the tags are user supplied or server supplied? Like if I was able to inject tags into the DOM, like realistically the browser won't know if it was me or if it was the server. Like so what if our input was just like an S? And we'll have a look at a demo now to kind of demonstrate that example. So let me cd into demos and then XSS. Oh wait, no. Client side injection, XSS, Flask, and then we will Python 3 app.py, open up the link in our browser. Cool. All right. So we have something that kind of looks like science today. So here's some hints on maybe where you get the flags. But let's look at what this does, right? So the first thing we have is like a filter comments thing. If I type hey filter comment, we now see that there's like a thing saying showing comments containing hey. If we actually make a comment saying like Jesse, hit new comment. Now it says Jesse. Now this website doesn't actually work. The filtering, I mean, it's just to kind of demonstrate what we're going to do in a bit. But yeah, like this is a commenting website, seems pretty cool. But of course, like when we see our user input reflected on a page, it starts concerning us because, well, that usually means that some sort of injection can occur because we have this unsanitized user input. And depending on how sanitized that is, depends on, can cause various issues. For example, if I was just to do like a H1, right? So in HTML, a H1 is a heading, so it will like just basically appear bigger. As you can see, like it appears bigger. And maybe that's okay because, if I'm making a comment and I want it to be a really cool comment, like, whoa, that was awesome. And then maybe I do a H2 here or H3 and say, going to watch it again, like it's a YouTube comment or something, hit enter. Like, whoa, that's a crazy formatting experience that we have here, right? Well, yes and no. Like, so this is cool and this is a great use case. But this inherently makes things a little bit scary if it's not handled correctly. So we're going to refresh the server just so I don't have to, oh, okay, whatever. I didn't want to see that comment, but that's okay. So like, that's kind of what HTML injection is. But like, for example, what happens if I did like an S, right? So an S is a strike through. Usually you go like, I'll just do it for an example. Like you do this, Jesse, and then it just strikes through the name. But what if I just did an opening S tag, right? So as you can see, it's just strict through everything, and kind of like broken it. Like, and if we see what's happening in the DOM here, like we go to this part where it started the strike through. Basically, the browser is like not going to crash. It's just going to say, well, you've given me an open strike through. Maybe you meant to just strike through everything. So I'm going to put closing tags around everything and put like a strike through tag around everything. And that's what's going to happen. And that's how it's going to work. So as you can see, like HTML injection can really break a website. And this website's demonstrating two different types of this injection. We either have reflected, which is up here. When I press filter comments, whatever I type in here is reflected on the front end. And also, conveniently, it exists on my URL parameter. So as you can see, like we have q is equal to, and then some URL encoded HTML tags. Now that's cool. And if I wanted someone to exploit this, I just copy this, open a new tab, hit paste, go to the new tab, and it's just the same page. But the worst one is the stored HTML injection. Because now if I was to do something like just do an opening div, hit new comment, now as you can see, this comment box is very strange because I've just like opened this div, which is just completely ruining the entire structure of the web page. And if I did something like body, for example, like this is just so strange now. and we're seeing that like the website's really getting messed up. And the problem is now, like, I'm just on localhost. If this was a real production website, all I have to do is just take someone and give them the link, or they just go into the link because they use this website, and it's so screwed for them. Like they can't do anything, and the website needs to be refreshed, and the database needs to be cleared. As you can see, like just by default, HTML injection is not good if you're not handling it correctly. Now, of course, like a legitimate use case for this whole like H1 thing is that, well, like, yeah, maybe you do want to format whatever you're typing and you want it to be a header. And that's fine, but we need to use some libraries to prevent us, or to allow us to do this, but then prevent us from doing other things. And an example library is something called DOM Purify, which is basically like a HTML injection prevention, I guess, or a sanitizer rather, and it'll also protect against the next thing we're going to be talking about in a bit. So all that being said, like, know your tags. Some are paired. A div tag, for example, needs a closing tag and an opening tag. Some can be unpaired, so an image tag. Now, I think you can actually, like, for example, if I did image and then a closing image tag. Wait, hold on. Let me actually put a source in it so that we can test if it works. Source equals, I don't have anything that I can easily remember. Yeah, so like this can have a closing tag and it'll be fine. So yeah, don't worry about too much if it needs to be closed, but you can always look it up too. But then we have this tag, the script tag. So what goes in here? Well, JavaScript. What is JavaScript? You might be asking as well. Like, it's pretty much just think of it as like Python, but for the web. It's a weakly typed language that basically allows you to execute lots of fun commands that modify the website, or send requests, or basically do anything a website can do. It is done with JavaScript. And this brings us to cross-site scripting. So I want to clarify something because this is a bit confusing. Cross-site scripting, XSS, is not actually cross-site. It's more like a JavaScript injection. The reason why is because way back in the day, I don't think I have a slide on this. Way back in the day, before same origin policy, you used to do something like loading this iframe, right? And let's say that I loaded bank.com in this iframe instead of, my slides. Now, I get someone who I know has a bank.com account, and I know they're logged in, and I send them to my website, which has an iframe with bank.com. Now, because same origin policy doesn't exist, their bank.com conveniently loads in my iframe, and then my JavaScript on my website is able to cross-site into bank.com and then steal the credentials from bank.com by executing JavaScript onto it. And as you can imagine, like, that is really, really bad. You can just steal people's credentials. But of course, same origin policy pretty much fixed that. And now we call what is basically JavaScript injection XSS. Yeah, so like your browser can often take inputs and place them inside the DOM, as we saw in the website before. And if you do this insecurely, you can execute arbitrary JavaScript. So we have, once again, two different types of XSS. We have reflected XSS. So for example, if we did a script tag, we did alert1, then a closing script tag, hit filter, we get a little box now that says alert1. This is a very common pattern you'll see with JavaScript injection or XSS, is that you'll do alert1 to test if your XSS is working. Because if you can get it to do alert1, well, that just means all you need to now do is change this to anything. You can change it to a fetch request. You can modify the DOM. Yeah, and like do lots of fun things. So the other thing is, this one up here was a reflected vulnerability, right? Like if I filter comments, if I go to the URL, all I need to do is send this URL to another person, hit new tab, paste it, and they get XSS as well. But what if we put this stored, right? Like what if we stored script alert1? Well, now, and I'll quickly just refresh, you can see that every time I access the page, it's alerting 1, which is really bad because now anyone who goes to this page gets this alert message. So as you can imagine, the stored vulnerability is always worse. And what's happening is that it's going and storing the input in the database. When someone loads up the website, it makes that request, it gets those messages, and you get XSS'd every single time. Yeah. So that is really basic XSS. Now we're going to take a look at something a bit more advanced, which is DOM-based XSS. Basically, if your XSS allows you to modify the actual DOM of the website, then you have DOM-based XSS. So we have this payload here. I'm going to break it down a little bit so you guys understand what it's doing. We have a constant in JavaScript. This is how you define a constant, and you say it's called pos. So a constant is just a variable that can never change. Pos meaning position. And now we have this like global object called document. Now, if you go to like a website, even this one, if you go to your console, you can actually also like execute JavaScript. If you just do document, you can see that we have like basically just the whole web page in the document, right? So the document also has lots of fun things to do, which are the different functions and parameters it has. Like, so for example, document.location. Now you have a whole object that just basically defines everything about that document.location. You can do document.get by ID, element by ID, and then we go look for an element in this DOM that has an ID. There is one. Maybe there isn't. We have a class element, maybe. Maybe we don't have an ID in there, so I can't really demonstrate that. Let's go by name, right? So we have a name is comment, and then we just put comment, hit enter, node list. So it gives us a list of elements that have that name comment, the length one, and then it's going to actually want us to get that element out of the list. So let's do maybe, oops, let's do paste. It's getting a new line. Okay, document.get elements by, actually get element by name, I think is actually the one that we want. Not a function. Okay, I lied. Get elements by name. Let's try just getting the first one. Input, right? So like we've just gotten a reference to the specific element. Now I extend that as I say, well, the value of that is now going to be equal to Jesse is the best. And now, as you can see, Jesse is the best is now in here. So obviously, like this requires you to be in the console, but you could store this in XSS and get it executed instantly, right? So look, I'm going to do a script tag. I'm going to paste this in, and then I'm just going to do this, the closing script tag. We're going to hit new comment. So we get alerted. This didn't quite work as I thought it might. I think that's because it loads before the document actually gets rendered. So we might actually see this here. Yeah, so what's happening is that it's trying to find the comment, but the comment doesn't exist. It actually exists below this part. So it didn't work quite as we might have expected. I wonder if I change this to this input little guy up here. If this thing has a name, Q. Let's try this instead. What if we did like Q and then script one? There you go. So because the comment exists below the Q, this Q up here is rendered first. We then render the comment, which executes the XSS, changing this query up here to be Jesse is the best. So as you can see, that's DOM-based XSS, and that can be quite bad as well. Like imagine if you had a bank form, and then someone stored an XSS on the bank form that basically just autofilled some credentials and then sent the request. Or autofilled pay Jesse $1 million, and then like the request is just sent like that. Like that is horrible, horrible vulnerability. Something else you could do is something like this. So as I've said, this is a position variable. We then get document.url, which just gets you the URL that you have, and then index of gets you the first index of a particular substring in another string. So URL is a string. We then get the index of the first position where context equals exists, and then we add 8 to it. So basically we're getting here, and then we're going to the end. where after the equals. Then we say document.write. So write just adds elements wherever this script is executed. Document.url.substring. So write the substring that starts after this context and then write everything after. So document.url.length. So let's take this, store it. As you can see, we now have our URL just sitting in the comment. But if we did something like this, where we go question mark context equals Jesse is amazing, hit enter, we now see that this is leaked into the comments. Now, you can imagine that if this was a fetch request instead, whenever, like, let's say that a token was sent to this particular website for some reason, whenever someone logs into this website or opens this website, I could send a fetch request with their token to my own webhook, and then all of a sudden I have everyone's tokens that's ever gone onto this website. So DOM-based XSS is really bad as well. Cool. Now, something to note is that XSS isn't just script tags. Like, for example, let's take a look at this payload. Image source equals X, on error equals alert1. So as we saw before, you can basically have an image, and then you say a source, which is basically where that image is located. It could be a link, or it could be like a relative URL. And then you have this on error thing, which basically means if I can't load this source, this is what happens. This JavaScript happens, in fact. Now, this is really bad because all you have to do is set source to like X, which is just like kind of meant to make it error, and then it will instantly on error and then alert1. So let's have a refresh of this. Get rid of our context. Let's chuck it up here. Image source X alert on error 1, and we get an alert, right? So like the image doesn't load, the error happens, the alert happens. So that's XSS, but through an image tag. And like similarly, if you potentially wanted to inject into some JavaScript code, you could change a variable that exists in JavaScript code instead. But yeah, like anytime you get user supplied context input into a JavaScript context, this is XSS. And this is a bunch of websites that you can have a look at. Payload all the things, OWASP, Hacktricks, Portswigger, they're all great. All great. I'm just going to check that I'm actually recording. Yeah, I am. Cool. Yeah. So breaking mitigations as well. So like one thing you might say was, oh, just like strip all of the HTML tags. Well, that's not realistic, but sometimes like you can use a different tag that has a different particular way of executing JavaScript. Sometimes there's different event handlers. So a body has an onload property that executes JavaScript. Or you can embed some dummy characters, kind of like how we did it previously, if it's just like a word sanitizer. Or use alternating case, like do that kind of thing. I don't think any of our challenges are going to be that easy, sadly, but that's an example. Actually, I lie. I think maybe one of our challenges is that easy, those bottom ones. Like here's a payload list of XSS vulnerabilities. Like these are all different payloads. Like we start, of course, with stuff like script, but then we go to images, we go to iframes, we go to all these different things. Like there's so many ways to get XSS, and you kind of just got to try it out and see if it works. Cool. We already went over cookies. We skipped through CSRF because it went to the bottom. Okay, so now that we understand what XSS is, I now want to talk about CSRF. So this is cross-site request forgery. So basically, you're tricking a user into performing an action. So for example, make them authorize a bank transaction that they didn't actually realize they were doing, or make them change their email or password. So it's kind of similar to SSRF. And let's have a look at the actual demo. Cool. CSRF. I think this is an npm start kind of experience. And we're going to click on these two. Okay, never mind. We're going to not do that. Localhost 3000. Okay, so we have this bank system. Of course, guys, it's just a bank. A login system. We're going to do admin. Okay, so hello admin, your current balance is $500. Cool. Okay. All right, let's go log in as me. So that's Jesse, secret password. Your current balance is 500. Okay, that's great. So for the sake of this, I'm just going to log in back to the admin to show that we're actually logged in. So important part of CSRF is that the person on said bank website has to be logged in, right? Or this won't work. Then we go to localhost 3001. I think my website's broken, right? Like there was meant to be an image here, like that would have been cool, right, guys? Let me have a look at this image. Oh, what on earth? Image source equals http localhost 3000 send to Jesse and amount is 4. Wait, does that mean that? Oh, I've just lost $4. That is CSRF, okay? Like that demonstration. What's happening here, right? So basically, we are logged in to localhost 3000. Now, my browser doesn't know that I am sending a request to localhost 3000 from localhost 3001 because this is just like getting an image source. Like when I go to the network tab, I hit refresh. We're just basically sending a random request to 3001. That's all the browser sees. So it's thinking, oh, okay, well, I have like a token that exists, a cookie already. That is how I authenticate this person. I'm just going to send that with the request because they're just trying to, access the bank and send some money to someone. But in actual fact, like what's happened here is we have just gone onto some guy's malicious website, and because we're logged into the bank still, and because our cookie that authenticates us is a has like no same site or anything on it, we have basically just transferred money ourselves by going to our website. And like obviously this could just be invisible. Like what if we went to for example form? Well, that was weird. It just logged into my account and now I have $442. Like what the hell happened here? Well, what happened here is that we went and accessed form on this browser, and then what it's actually done in the back end is sent a request to this website's slash form. There's a post request slash form. You guys can't quite see it. It looks something like this, right? There's just a method post. It sent that post request and then transferred my money. So as you can imagine, like you could literally just click a link and you get CSRF'd. It's really, really bad. And like another kind of more obvious example is like this click me. Like what I could do is, as you can see, this click me, all it does is do the same thing, just send a link, and now you've lost more money. So CSRF is really bad, and all it requires you to be is logged in. And once you're logged in, you can just have all your money taken from you. And that's really bad. Now, that being said, modern times, we have CSRF tokens, which kind of prevent this from happening. But that is what CSRF is. It's like stealing or making requests for people without them actually wanting to make that request or intending to make that request. Cool. We're now going to go into clickjacking, now that we've talked about CSRF a little bit. So clickjacking is basically when a fake form is sitting underneath a real form. So if you then try to interact with the fake form, you'll accidentally interact with the real one. So this could either be a local or an external form. So either so the same form, and then you switch the confirm or cancel buttons, or an external one, which is like an invisible iframe with a higher Z index. So it's just sitting on top. This doesn't make sense much. It doesn't make too much sense until you've actually seen it in action. So we'll just have a look. So we have the same situation. We've got localhost 3000, and we have this cool bookstore. It says I must be logged in to make a purchase, and that's cool. Maybe I don't want to log in. I haven't actually done this without logging in, but I want to see what happens. We also have localhost 3001. You've won $5 million. All you have to do is accept the prize. All right, cool. Sounds good to me. Okay, I don't know what happened there. We go inspect element. hit the network tab and then press it again. Nothing's actually happening. Okay, so that's interesting. Nothing happened. What if I log in? Okay. What about now? What does that my network do? Oh, oh, I've just sent a purchase request to localhost 3000 to buy the Fortnite $5 million book. Like if we for testing purposes, if we clicked this on localhost 3000, we actually see that the exact same request is sent. We've just sent, like, how does that even happen? Like, this is a completely different website. There's nothing here. I just clicked accept the prize. If we click on the accept the prize, like, or if we, sorry, look for it in the elements tab, accept the prize is just like some weird submit button. Oh, but there's an iframe to localhost 3000. Okay, so this is clickjacking. And how does it work? Like, it's really interesting. So basically, there's an iframe sitting above this entire page that is iframing onto our localhost, and it's invisible. Let's put it to 0.5. We now see a convenient little iframe, and then when my tab is closed, hold on. Let's do that again. Let me click on the iframe, hit 0.5. As you can see, when I go to accept the prize, like this button here is very, very close to the purchase button. Now, what I actually could have done is like perfectly aligned it right on top. Like if I did 300 pixels instead, and all of a sudden, like I'm only ever clicking purchase. It's just that it's invisible, so I can't see that it's purchase, but you can kind of see it here because the purchase button is a bit bigger and I'm now hovering over nothing. So what's happening here is I am clickjacking, like I'm hijacking the click to, instead of pressing the give me free money, I press purchase. And that interaction tricks people into purchasing, a $5 million book, perhaps. And clickjacking is cool because it could make you send a request that you didn't intend to do. So it's kind of a way to create this XSS or create this experience that is really, really rough if it happens. Yeah, that's kind of the whole deal with clickjacking. Yeah, that kind of brings me to the end of this tutorial. There's not much else to say. I would have loved to go through some example questions. I might do that in the next week because I don't think it's reasonable for me to guess what people want me to cover. But yeah, hopefully that was helpful. I appreciate all of you. Thank you for watching if you are. And I'll see you guys later.